Hello, can everyone hear me? Okay, thank you so much, guys. Thank you so much for joining me. I don't know what is this with me and conferences that they always give me a slot post-lunch, and it is really, really hard to entertain people post-lunch. I myself is feeling sleepy. But before I begin, I would like to request all of you guys to please stand and give a huge, huge round of applause to Mobile Era organizers. Because I have been on the other side of the table, man, and it's not easy. I won't do it again, it's that hard. So come on, you guys. A big round of applause for Mobile Era. Thank you so much, Hampers, Hasib, and Jamie. Thank you so much, you guys. Okay, now let's begin. So it was really hard for me to choose what should be on the very first slide of my presentation so that it is relevant to the people. Anybody knows the context for this slide? Anyone?
It disappeared.
Oh, sorry. Magic. How about now? No one? So she is Alison Felix, and she recently broke the record of Usain Bolt, world's fastest man. She recently did that in September, and she came back. She came back to Olympics after many, many years, and it was her first race, and she broke that record. So she made a history in September 2019. So yeah, I mean, I guess you guys should know this. Why I put up this picture? Because maybe our app cannot be as fast as Alison Felix, but it can be a little bit faster than whatever the app that we use right now in today's world. So that's why my today's topic, though in the speaker card and everywhere you will see Android Studio, swipe this profile right, but I took the liberty to change the title of my talk and named it as Mobile App Performance. Believe me, it's better for you guys only because the content is a little better now. Okay, so let's begin. Who am I? Apart from my name, which Hasib told, that Renu Yadav. I'm a cheap traveler. What does that mean? I actually look for conferences like Mobile Era and submit thousands of CFPs and just pray that they accept me and sponsor my travel. That's what I do. I have started doing this. I mean, I learned this trick last year. And since then, I have visited 6 countries, which I would have never visited on my own. It's really expensive, man. Oslo, Norway, Scandinavian, I would not have bought tickets for this. So I am cheap traveler. That's my identity. Second, I'm a WW code. It's Women Who Code. It's in more than 80 cities. It's an international organization. I am the network lead in Singapore for that organization. And if I get time about these 2 things, I'm an engineering lead at Grab. Grab, how many of you know what Grab is? It's a company name. What Grab does, of course, apart from you. Anyone? No? Okay, so it's time to, oh, by the way, this is how I look on LinkedIn. So Grab actually, in this world's map, Grab is basically located where you see the green circle. It started as a Grab taxi company in 2012. It's a 7-year-old company. It started as a taxi business. You can just say that it was the Uber of Southeast Asia until last year when we took over Uber's business. So now it is Grab of Southeast Asia. It started as a taxi business, but it is not only in taxi right now. It is Grab Taxi, Grab Food, Grab Delivery, Grab Pay. Basically, they're trying to be everyday super app. The moment you wake up and the moment your day ends, we want to be with you literally at every step. That's what Grab is about. Currently, as I mentioned, that it started 2012 from Malaysia, but right now it is serving in 8 countries. And I remember those names as well. It's Singapore, Malaysia, Philippines, Myanmar, Cambodia, Vietnam, Thailand. Is it 8 already? I hope so. We have 100, some thousand, some plus downloads. And if that doesn't give you a sense that how big our user base is, this was a recent news headline around July 2019. We hit our 2 billion rides. Now, what does it mean? Basically, there were 103 rides that were happening concurrently in more than 7 countries. There was around 710 kilometers of distance were being traveled at the same time. There were 540 chat messages were exchanged, and the longest ride was like 26 kilometers, and the shortest ride was 640 meter, like 640 meter. People take taxi for 500 or 600 meters. And here in Oslo, we are walking for 2 kilometers. So yeah, it's a different world over there. So basically, this is to tell you that Grab has grown really, really fast. It's all over the news, and it has made history in many, many areas. Okay, then now what makes it challenging? Exactly because of the above mentioned things, that it started with transport. We support cars, scooter, all type of transport. Then we support food deliveries and just the delivery, like the courier deliveries. We deliver groceries, and it has a huge payment ecosystem. Like, we are talking about payment in a way that not only you can pay your bills, you can transfer money to your friend in terms of Grab Pay. Literally in Singapore, you walk over to every shop, even in the food court, like local stores, and you can pay using Grab Pay. That's how big it is. And yes, actually, they are microfinancing early stage startups and other entrepreneurs. So it is a big thing. And many more things. And exactly these things, they make it challenging because it happens, all of it happens in a single app. And that's why mobile app performance became an issue for us. Because now that we have delivered so many features within a single app, our app doesn't really work. For people like me who is only interested in one service of Grab, which is, let's say, transport. But my app supports thousands of other services, and that is making me not using transport as well. And that is a big, big business threat to Grab. Like, how do we actually make it happen? Now, how do you know that there's a mobile app performance issue? How do you guys know whether your app is not performing well? Anyone?
Or bad reviews.
Sure, yeah. Actually, you're right. But before that, your annoying friends. All of my friends, like, they're always complaining about how bad is the app that I work on. I mean, not that they always anyhow appreciate it at any point of time, but they always complain about it. And we have to remember that all of us has those annoying friends, and if you don't have that, that means we are the ones. And then actually exactly like this gentleman mentioned, that app reviews. If I go today to the Play Store and I look at our reviews, and this is actually, I took the screenshot, I removed the dates and all those things just to maintain some privacy. I mean, though there's no privacy here, but look at the reviews. Your app is slow, your app is really slow. I would have given it a 5-star if your app was a little bit faster. Your app is bloated, it is extremely slow, it is not fast. All of these reviews are saying the same thing. And just to let you know, our app rating is not that bad, it's 4.6. And still, people can feel it because that's the demand right now. That as a Grab, as a company, if you're delivering so many services, but we demand more than that. So Play Store reviews was exactly the very first signal. What are the other signals? We have other signals, NPS, Net Promoter Score, Android Vitals. Actually, if you opt in for that, you can get a lot of data from Android Vitals. And third one, so there are like some proactive actions, which is like profiling. So when you actually start profiling your app, and that's when you realize that something is wrong in your app and it is not behaving properly. These were the main signals that we looked at. Now, just a little bit about Android Vitals. I'm sure many of you would already know that it came 2 years back. It just collects and shows app performance data in Vital Dashboard. Where is the Vital Dashboard? It's in the Play console, a Google developer Play console. And it collects your data based on multiple dimensions: battery usages, stability, rendering time, app startup time, permission. And it collects your data, and then you can funnel your data, filter your data based on all these 7-8 things. One good thing, and that why we did this, because when we opt in, we started getting these notifications very frequently. Actually, Android Vital was alarming us faster than Fabric. So this is called as bad behavior. So if your app's crash rate goes below a certain threshold, they alarm you. They send you a notification. And how it actually threatens your app rating is that in your Play Store, when you go and search for your app, it will not be listed in the top 10 apps if it goes below bad behavior. So that is basically a pure threat to your business. So those were the signals, and we said that, okay, at Grab now, mobile app performance, it's a threat and it's a challenge that we need to look into. But what exactly did we want to focus on inside the mobile app performance? We wanted to focus on app size. And what is app size? App size is basically the then again, it was not a proactive action. It is because our app size is more than 70 MB right now, and the limit is 100 MB without extension files. So, I mean, it is something not like that we were actually trying to fix something. This is something like that we are being forced to improve on these things. Second is speed. This is from the Play Store reviews, because everybody mentioned that your app is really, really slow. Here, by speed, I mean interaction speed, that you interact with your speed and how fast it reacts, and you go to the next page. Network usages, all the time, all the time. I think I even got a call from a user because we were doing some research, and they always say that, hey, just for a single ride, you ate my 6 GB of data. And I'm like, okay, sure. And same way battery consumption, that with a single ride, the battery draining happening is at like, from 60% down, 60% it went down to 10%. So, and these were the questions we really could not answer at that time because we did not know what was going wrong. We mainly looked at these 4. So the very first thing, which is app size, and size matters. What inside this we wanted to look at. But before I want to go into what exactly inside the app size that we looked at, I would like to show this data, and this is from Google I/O, that if your app is 10 MB and there is another app which is 100 MB, the 100 MB app will have 30% lesser downloads. On a similar very note, though you can already derive it, but every 3 MB corresponds to 1% installation. So you can imagine every time, almost every time, your app size increases by 3 MB, how many number of installations you gonna drop because your size is increasing. Okay, what to do with the fact? Inside the app size, what are the different types of size? Because it's when we say that, your app is 70 MB, because we're looking only at one metric, and that is the upload size. 70 MB is the upload size, which is the APK size. Then there's a download size. And then there is an APK on disk size. Recently, we got one feedback from a user, and that was on Twitter, that Grab's app size on my device is 900 MB. And you really cannot answer these kind of questions. And thank God I'm not a marketing person, because marketing people are the one who have to respond to those queries on social media. So these were the main things. And actually, we got into touch with Google DevRels, and then we said that we literally requested them that help us, because they can really do a deep analysis of your application. That's what they are getting paid for, so that's their job to do that. And they can send you that report so that you can look at the derived data. So you can use multi-APK app bundle, as Osama, he just explained. And then you can use static resources. Do not use localized images, if possible. Use network images over local. Shrink resources as much as possible. Reuse drawables. And then there is this thing, resources.arc. Application resources, ARSC's application resources. And this is something, to be honest, even after being an Android developer for 4.5 or 5 years, I did not know about. Now, what is resources.arc? Actually, it fits into your APK file. It's a resources string ID values. You know, when you have a string, let's say hello, that string, and you have localization of that string into different languages, where does the memory mapping happens? How does, when a user is opening your app into, let's say, Indonesian language, like Bahasa language, how does it know from which memory the string has to be picked up? That's where the resources ARSC file comes into picture. It is stored in the APK file. And the bad news is that it is compressed when you upload the APK. But when it is in your device, it is in decompressed format, because it has to do the in-memory mapping for your resources. Now let's analyze this a little bit more. Let's say you have 5 strings, and there are 5 mapping on the memory. For that, each taking 4 bytes, so total 20 byte size of the 5 strings. Now let's say you have another config. In that config, the only configuration that is provided for string feature. For rest of the strings, which we do normally, because sometimes I only want to localize, or I only want to provide a different translation for one particular string and not for others. So I only provided a config for feature in v21 config, and I did not do anything. So imagine strings v21, it is containing only one string, which is feature. Okay, looks good because I'm only defining one string, but in your resources.arc, you will see this. With only one string, it is still 20 bytes in V21. Where does that lead us? So basically, this is just rough calculation with random numbers. That, hey, if you have 3,500 null entries, and you're supporting 50 languages, which Uber already does soon. I mean, hopefully we will also be doing that. And each taking 4 bytes, you're losing 700 kilobytes direct away. This was one of the problems for us. We did this, and actually we saved few MBs, not just kilobytes. I cannot share the full data, of course, because of the confidentiality, which were the strings that we were really facing problems with. But there's an AAPT tool, and if you go to the Google and you just search AAPT resources.arsc, it can analyze and it can present you the application resources file in a beautiful table, and you will directly see the null entries for the string resources, which you have never imagined that, okay, this is how the mapping is done. So this is something which you really, really should look at, because it was an unexplored territory for us, and it saved us 2 to 3 MBs, which was a huge gain because it came out of nowhere. We weren't even looking at this improvement. Now the second thing, app speed. Actually, this is a project that I started working in July, but at Grab we have been working on this project for last 10 months. And I'm also writing a technical blog for that. Hopefully that will be published soon. So all you guys would, then you guys can take a look at that what exactly the steps that we took. We actually gained 60 to 70% of the speed improvements. That is a really, really huge amount. Now, we all know that, okay, for any Android application, and we did that for Android and iOS both, but of course, I'm going to focus only on Android. So we know that there's a cold start, hot start, warm start, right? Out of all these, cold start is the slowest because there's nothing in memory. System has to do everything from the scratch. So this is the time, like in terms of speed, that hot start is the fastest, then warm start, and then the cold start. So basically, for us to improve the speed, we had to go with the cold start, because if you improve the cold start, anyways, the hot start and warm start will be improved. Inside the cold start, what happens? The very first step, and because we were going really deep into our app startup time, the very first thing that happens when you click on the app icon, the DAX loading happens. And then the application initialization happen, and then the activity initialization happen. Very simple, basic 3 steps when you launch any application. Okay. Index loading. So your APK, and it actually relates to what Osama presented a little while ago. So you have DEX file. Basically, this is your source bytes, right? When you look at look into your APK, the DEX file size, you will say, oh, it's not that big. Maybe it's just, let's say, 5 MB. What happens when the application gets installed on the device? Actually, the inflation ratio is 5 times. The DEX file size increases by 5 times. So if you have a 5 MB DEX file, the size would be around 25 to 30 MB on the disk, because it is inflated. Because then we have ART and then we have JIT, all those compilations in place, because it has to do some pre-processing, keep it in memory so that it can run faster. But the higher the DEX loading size, slower the app startup time. So for us, the challenge again was to reduce this DEX loading time. But to be honest, we couldn't do it. The only solution to that is delete your code. But delete your code in what sense? We cannot delete features, right? That's what we are getting paid for, to build those features, not to delete them. So use DexGuard. We are not using DexGuard at Grab right now, but if you are already using, that's really amazing, because DexGuard provides a lot of optimizations for your DEX files. A lot of optimizations. We are in process of enabling the DexGuard, but of course we have a lot of challenges in enabling that. App bundle, because when your code itself, when your source code itself is smaller, the DEX file will be smaller. With app bundle, you can have conditional deliveries, you can have dynamic deliveries. So for sure, your DEX file gonna be smaller. Code cleanup, and this is true, there is no exaggeration. We deleted 3 of our features, which were not used. Because as in a company like Grab and in any other organization, when we are going with that fast pace, we never look back and see what we are not using anymore. All we talk about is, we're going to use this in next month, or we're going to build this in next month, and there is no cleanup time. But because, of course, we were being forced to improve our app start speed and everything, we did code cleanup, and we actually reduced by a few bytes, not that much. But DAX loading was not successful for us. And if you look at recently published videos from Android Dev Summit, if your DAX loading takes around 300 to 400 milliseconds, it's still optimized, because it's really hard to optimize to make DAX loading faster than that, and ours is already around that. The main challenge for us was application initialization. That was something which was in our control. So this is where all library initialization happened. For example, social login. At Grab, we provide social login, Google and Facebook. You do Crashlytics initialization, and you have your in-house SDKs, whether it's Chat SDK, Analytics SDK, and whatnot, and some millions more, because literally there are millions more. Now, but before we could go into application initialization, and here I'm talking about that we were really struggling even for milliseconds. Like, forget about when we talk in seconds or minutes. Here, literally our talk of time unit was milliseconds. Okay, how many milliseconds does this function take? But before we could go into that, we needed to define a measurement for how do we measure our application initialization time, on what measurement unit, and then that's when we go into percentile. Very basic definition, a value below which a given percentage of observation falls. We took P50, P90, and 95. Again, nothing extraordinary, something which is used by almost all the industries. And then we did instrumentation. We literally went for each functions. We started a stopwatch and we ended a stopwatch. We calculated the time and we sent it as instrumentation event, just like any other analytics event, because we didn't know how else to do it. We did that, and then we built similar graph. What this graph showed us? This graph basically showed us that the metrics on the left, right, I mean the bigger bar, it is the highest contributing metric to your application initialization. When we build these metrics, we publish them on big TV everywhere so that we could prove it to everyone that, hey, this is the function which is taking the most time. And from here, our journey became a little easier, because we know now, then we knew that where to focus. And we started like striking off metric by metric by metric by metric until we actually gained 60% improvement. So how exactly did we improve those metrics? Remove. And this is again, I mean, no matter how much I focus on this, keep the libraries only if you really, 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 really need it. Otherwise, there's no point in providing something which is only used for 0.001% of your users. You cannot solve a problem for 100% of your users. So you have to keep this in mind. Whatever you can remove, you have to remove. We also removed animation at our splash. It was a 1-second animation. Beautiful to look at, but every time, if I'm a user and I'm opening that app 10 times in a day, I don't think I'll find it any more beautiful if I look at it 10 times, right? So we went into a mode where we started thinking that, are we designing our application for everyday user? And we removed animation, and that directly gave us 1 second of gain. Defer or lazy. At the application initialization, when I mentioned that we have social login libraries, we have Crashlytics and all those things, we started deferring those initialization. For example, when a user is already logged in, we don't need to initialize Facebook or Google, because a user is already logged in. That's the main purpose of social SDKs. And if you can postpone that to post app start, better than good. Core routines. Oh, it was a hard call, because it's a love-hate relationship for many people, that whether to go for it or not go for it, and then there's a learning curve as well for core routines. But whatever we are doing at the application initialization level, we started launching them as core routines. So that means the initialization happens in the background. Don't ask me technical details for this. The last thing, caching, actually. Because if you look at, I mean, I should have posted that video of ours, our application, but actually a lot of places we were directly fetching the fresh content, which did not make sense. For example, at Grab, I mean, I'm sorry that I don't have a screenshot here, but you see the service styles. The service styles are, you must have seen Uber, right? Like, or have you seen Didi, China Didi app or something like that? So where you see the tiles that, okay, you click on transport, you click on food, and you go there. And those kind of things, they don't change frequently. So there is no need in fetching those things every time user comes to that screen, because those things, they change only when user travels. And as an end user, like, how frequently would you travel? Would you travel 10 times a day in different countries? Not really, right? So that is something that we enabled. and boom. By removing, and of course, this is not the exact amount of time because that information is confidential. So please don't quote me that by removing at Grab, they gained 3 seconds. So this is very rough estimation. We gained 3 seconds by removing the libraries. We gained 2 seconds by lazily loading, 300 milliseconds by coroutines because we really could not put everything into background, and 2.5 seconds by enabling caching. It's 3 to 5 plus something, it's a huge number, right? So this is the improvement we got in 10 months. And did we do something really like scientific stuff or something really out of the box? No. What we did that we actually instrumented our code, and then we started realizing where does the problem lie. We followed a very simple if-else statement. And seriously, this is on big screens inside our development team now. For any library or for any code, we follow that, can it be removed? Then yes, please remove it. If not, can it be lazily loaded? Then yes, please lazy load it. Can it be done in background? Then yes, move it to background. If not, then I'm sorry. You really can't do anything. This is what's gonna happen. This is what is happening to us. Okay, so that was all for app speed. How did we actually gain, what specific tips we gotten from that. But when we actually got into this app performance improvement, we went into profiling more as well, of course. And then how do you determine that how much time a function takes then? Because we follow 1 week release cycle. And when you put in some improvement, you cannot wait for 1 week to see whether it has actually improved or not, right? And I'm just talking about 1 week release cycle because that's where your app goes to the Play Store. And recently with Play Store reviews, oh, God knows what's happening. Like it's worse than App Store reviews. It takes 3 days, it takes 4 days, and whatnot. But we started profiling our application, which we were doing a little bit earlier as well. So basically 4 types of profiling: network, energy, memory, and CPU. Now, all the time what happens that whenever I want to demo, of course, either the emulator doesn't work. What happened to this? Sorry. Oh. I can't see my... Okay. And I knew that this time also it won't work, so I have already stored a session, and so that it doesn't ditch me, and it saves my time as well. But yeah. Okay, so it came with Android Studio 3.2. I hope that most of you are already aware of it. If you are not, then this is the time that you get alerted and start exploring this territory. These are the sessions which you can store. Basically, you can profile your application into 4 different categories: CPU, memory, network, and energy. There was one particular thing that we started looking at. So basically, if you are profiling network, so I have a very simple application in which there are 4 functions. Do I have emulator here? No. You can download an image, you can put a timer of 10 seconds, and these are just the 2 functions. But whenever there is a network operation, you see a spike in your network profiling. And then you can go here that what was the image downloaded, what was the response, what was the request, what was the call stack. Very simple, but this is not I want to focus on. I'm going to focus on energy. What is energy? Basically, your mobile device's energy is mainly consumed by 3 things: your CPU, your location, and your network. You can see the highlighted top 3 things. And then it also shows you the system events, that how many location requests you have right now, how many wake logs you have right now, how many alarms and jobs you have right now. Now, with the timer, when I put the timer, so what I did that when I started the timer, I acquired the wake log from the system, and I set an alarm for 10 seconds. And then post the alarm triggers, then I release the wake log. So you see those red, purple, green rainbow lights at the bottom? If you actually select this, and if you highlight this, earlier you were seeing that wake log was 0 and alarms and jobs were 0, right? But here you can see that there was 1 wake log that was acquired by your application and 1 alarm and job that was running. Now, how does it help us? Actually, you can go, I mean, this is very redundant information, but you can click on it. You can directly go to the source code that where it was acquired and where it was released. But the point is, we realized, and same as happening in this application, that there were few wake logs which we acquired, but we never released. And imagine and especially for slower Android devices, because earlier we were, I mean, that is again, a mistake that we were making, that we were still supporting API 16. And this is something, because then it's hard to improve the performance for all kind of API versions. And especially on smaller Android versions, API versions, if you have wake clocks, alarm clocks running, it just drains your system, it just drains your battery. The CPU resources are already acquired up, and then everything becomes slow. So this gave us a huge insight in how many wake clocks we had, which we did not release. Actually, if you go further, it also shows you the location, because now you can see that there is a location request as well. So there were a few screens in our application where we were still acquiring the location trigger, but we did not need it. So basically, energy profiling, it really helped us in ways where we realized that screen by screen, these are the smaller improvements that we could do. And it actually helped us in solving the problems for user, where they said that your single ride actually drained my battery by 60%. It really helped us. These were the main cause. I mean, not the only cause, but these were the main cause for that. Okay, this was the small demo. So just to share two special lessons that we learned during these 10 months, tracking and benchmarking is really important. If you do not know where you stand, you would not know where you want to go, right? So you have to track and you have to benchmark what is the current value for your application. You can either use Android Vitals. Firebase provides a tons of app start performance data. In our case, we use instrumentation because we wanted to analyze the data in a more granular form. So we used our own analytics, in-house analytics SDK. The second very important lesson that we learned, that understand users and their perception. Basically, we conducted user research in Vietnam and Indonesia and other Southeast Asian countries as well. And you would be surprised, because what app speed means to us does not necessarily mean the same thing to them. Because to them, there's an offline and online experience, and no matter how fast you can interact with your application, to them it also matters how fast your driver comes, right? And that is not in the control of application. So it is also important to understand that, because they are the people who review your app, they are the people who leave 5-star or 4-star on the app store, they are the people who increases or decreases the NPS. So conduct user research and find out what does fast means to the users. And of course, like, user is your God, like user is the main client, you have to act according to them. So just to summarize, mobile app performance, it became a challenge for Grab. Actually, how did we get low performance signals? And then how did we improve the app size and app start speed? The main two lessons that were learned was tracking and the user research is important, and how to make use of Android Studio profiling so that you can get deep dive into your energy and CPU performance. These are the references. The source code is already on GitHub. If you want to read really more about resources.arsc, because I was also intrigued by this new thing that I came to know, ARSC Blamer is the tool that you can use to actually see the beautiful table from application resources file. So please go to these links. And questions. Yes, please.
Do you ever have to target low-cost, slow, not very powerful devices? Because anything can look nice and smooth and performant on your high-end development phone, but when it comes to the user, things aren't so good.
So to repeat the question, her question is, of course, everything looks good on a high-end smooth phone, right? And maybe as developers, we are already using high-end smartphones, so we don't realize those performance issues. But what about improving performance on lower and slow Android devices, right? And that's what I meant, that because we were still supporting API 16 and our P95, it looks really worse. And the hardest challenge is to improve P95. And P95 are the users who have the slowest devices. So the very first step that we took, actually we were supporting API 15. I'm sorry, and I'm ashamed to say that, but yeah, the very first step that we took, that we removed the support of API 15. And we went up to API 16. We also want to go up and improve it until API 21, but of course that's not how it works, because there's a business to run. But the one thing that we do in order to understand that there's a difference between how end users see it and how we see it, we conduct these user research, and we actually look at our P95 numbers. We do not have a device lab. We do not have a device lab which runs our application on high-end phones and then calculate the numbers. We actually look at P95 numbers and try to improve them. And even in our local testing, we now have P50, 90, 95 devices, and then accordingly we act.
So if you see that the percentage of the users with APIs below this threshold is under a certain percent, then you can drop support.
Yes, actually, and because to be honest, there is no point in making that app faster for that phone, because it's not just about Grab. Like, it's about on that phone, the resources, the capacity is also limited, very limited. So there would be, and I guess the trade-off investment versus the gain, it would not be worth it. And yes, you would have to make such decisions that you would have to collect that. It wasn't easy for us just to drop API 15. You have to go through a certain process. You have to go through product marketing, business people. You have to explain them that these are the users who are on API 15. Even if they are not on Grab, you would not lose much business because they only understand business language, right? So you have to explain it to them that this is the gain. And even if we try to improve, we will not be able to improve it by that much. And that's how we make this decision. That's why it's harder for us to drop API 16 because a very large chunk of users are on API 16 and 19 KitKat. Yeah.